Hello everyone, I'm Jaspreet and I'm present here for conducting the chemistry of +1 standard. Students, as we all know that the very first chapter of our chemistry for the +1 students is some basic concepts of chemistry, and here I am to help you out with this particular chapter. Before studying those chemical reactions and knowing about the chemistry, the very first thing I think everyone must know is what is a chemistry. So when I talk about chemistry, the word chemistry, it means something that refers to universe. Because our universe is made up of atoms and the molecules, and chemistry is a subject that tells us about the study of the universe. What are the changes that is actually taking place in a particular universe? In this universe, not the particular, but in this universe. So whenever I talk about the chemistry, it's there everywhere. The things I start doing from the morning, for example, brushing of my teeth, or if I'm combing my hair, the comb I'm using, it's a product of the chemistry. The nylon or we could say that the clothes I'm wearing, it's also the product of the chemistry. So chemistry is everywhere. Whatever we do, I'm speaking because the molecules or the atoms, they are vibrating in the air and it is actually producing the sound. That is also a chemistry. So chemistry is a subject that we can say that it helps us to study about the universe and the chemical changes that is particularly taking place in this universe. Moving ahead to the applications of the chemistry. Few of them I have already mentioned, but I'll let you know how chemistry is there living with us every day. So when I talk about living with the chemistry, the clothes I'm wearing, these are the chemical products. The color of my clothes, it's just because of this, the chemical reaction has taken place. Might be the process of the adsorption that took place to give the color to this particular cloth. It might be the cosmetics I used. These are also the chemical products, such as hot sunny days, and I applied the sunscreen, and that particular sunscreen is also a chemical product. Moving ahead, the food I ate today, this morning only, the food is made up of the biomolecules, proteins, having some fats, they are also the chemical products. Hence, chemistry is everywhere. The transportation I used this morning, it used the fuel, petrol and diesel. That is also, the chemical products. So I believe that chemistry, we are the human beings who are living with the chemistry. Chemistry is everywhere. So altogether, can I say this is a subject which is a study of atoms and molecules that makes up the universe and the chemical changes that is taking place over there? So yes, chemistry is the study of the atoms and the molecules that is making up this universe and telling us about the chemical changes that are happening there. Moving ahead, let's talk about the very first thing, the matter. What's a matter? Am I using this duster? And this duster, is this a matter or not? Please let me know. Yes, this duster that I'm using, it's a matter. How? How does this duster, it comes under the category of the matter? The very first thing, what is a matter? When I talk about matter, it's something which is having a mass and it occupies a space. For example, whitener, the pen, whatever I use, it's having some mass. Moreover, it's occupying a space. That is why it comes under the category of the matter. When we talk about the chemistry, the matter, it gets classified on the basis of the two categories. The very first one, the physical classification. The physical classification of the matter and the chemical classification of the matter. Now, matter is a term which is very important in the chemistry because everything we study will get to know, okay, this is the matter, the particular substance which is being used over here. So matter, when I talk about the physical, in that physical concept, when the category is the physical, it is further divided into the three categories. There is a solid, liquid and the gas. Now, as we all know that this duster is a solid. Now, why we call this duster a solid. The reason being, when we talk about the physical classification, it means on the basis of the physical structure, we are categorizing that particular substance. This duster, it comes under the category of the solid, since we can see that the atoms that are combining here, they are very close together. The atoms are closely packed in this particular duster. So, kabhi bhi solid की बात करते हैं, the very first thing that should be there to occur in our mind, that the particles, they are very closely packed. So, when I talk about the particles, they are closely packed, it means they might not have any intermolecular space of the interaction. So, this is a structure that I am drawing over here that tell me, we could say that about the solids. This is something which is about the solid. Let me write about the properties of the solid over here so that you can have the better clarification of the things. I guess everyone is clear that solid is something that comes under the physical classification of the matter. So very first thing, then when I talk about the matter, they are having a definite shape, you know, a duster. It's having a proper shape. This one, I could say that, okay, this is in a form of a rectangle which I am having. If I talk about this whitener, I could say that it is a cylindrical form which is present over here. So when I talk about the solid, the very first thing that should be there to our mind, definite shape. And yes, if it is having a definite shape, it's having a definite volume. Now, please have a look over here. Since the atoms, they are very closely packed, that means to say that there is a least intermolecular space which is present between the particles. And if they are having the least intermolecular space, means they are having the strong intermolecular forces of the attraction. So this is something that we get to know about the solids. They are having a definite shape and a definite volume. They are having the least intermolecular space, and they are having the strong intermolecular forces of the attraction that actually hold these solid particles very close together, and hence they are responsible for giving a definite shape and the definite volume to any particular substance. For example, wood, pen, paper, anything we could say that in which the molecules, they are very closely packed, they don't have any space to vibrate about that particular position, that particles is a solid. Moving ahead to the liquid. Now, liquid is any substance, any matter which we could say that it's not having a definite shape, but it's having a definite volume. Now, why does water, if we talk about water, do you think that it is having a particular shape? Is it having a definite shape? No, not at all. क्योंकि हमें पता है कि water किसी भी substance की, किसी भी solid में हम अगर उसको we are pouring it, it can take the shape of that particular container. So water की अपनी कोई भी shape नहीं है. Similarly, any of the liquid, it does not have its own shape. It always takes the shape of that particular container. So for the liquids, this is actually the structure, we could say that, which every liquid it displays. Like the molecules, they are not closely packed. From here, I could easily get that these molecules, they are actually having some intermolecular spaces in between them. If they are having some intermolecular spaces, it means that this is something which is actually getting low, which is actually getting less. So, अगर उनमें intermolecular forces of spaces ज़्यादा हैं, तो उनकी जो forces of attraction होगी, डेफिनेटली वो कम हो जाएंगी. अगर उनकी फोर्सेस ऑफ अट्रैक्शन कम हो जाती है, इसका मतलब है नाउ दे कांट गिव द पर्टिकुलर शेप, or they will get the shape of the substance or a container in which it is being poured. So liquid does not have its own shape. It always takes the shape of container. But it's always having a definite volume. I hope it's clear. Moving ahead to the third category of the physical classification of the matter is a gas. So when I talk about the gas, let me draw it over here. When I talk about the gas, as we could here see that in the solids, we were having the least, space between the particles that were making up that particular solid here. There were the space were there between a small space in between the two particles of the liquid. But when I talk about the gas, the particles, they were loosely placed in that particular material. So in a gas we could say that जो particles होते हैं उनमें बहुत ज़्यादा space होती है. They are having a very large intermolecular spaces. अगर मान लो दो particles हैं जिनमें large intermolecular forces हैं, do you think they will be having a strong forces of attraction? No, उनमें बहुत ही कम forces of attraction होंगे. And from here I could say that gases, they neither have the definite shape nor they are having the definite volume. I'll repeat once again all the key points for the solid, liquids and the gases. The very first thing, solids, as we could see from here that they are very closely packed, जिसका मतलब है कि उनकी एक proper shape होगी, उनकी एक definite shape and definite volume होगी. Secondly, when I look towards the liquid, I could get it from here कि liquid में जो particles हैं उनकी spaces थोड़ी ज़्यादा होती है as compared to the solid. That particularly means that इनकी खुद की shape नहीं हो सकती, लेकिन ये किसी भी container की shape को they can achieve the shape of any of the container, and it means that doesn't mean they won't be having a definite volume, but they are always carrying a definite volume. And the third one, the gases. Though there are large intermolecular spaces over here, which concludes that there will be the least intermolecular forces of the attraction, that gives us this thing that जो gases होती हैं उनकी अपनी कोई भी shape नहीं होती, उनकी अपनी कोई भी volume नहीं होती. So gases, they neither have definite shape nor definite volume. This is actually, we could say that, the physical classification of the matter. So I hope it's clear. And you know what? There is one interesting fact. What is that? Now the solid, it can be converted to the liquid. And the liquid, it can be further converted to a gas. So this is something which is really interesting about chemistry. Now how does it take place? हम लोग अगर, these are actually the hot sunny days. समर सीज़न इज़ गोइंग ऑन. सो हमें पता है कि अगर हम लोग पानी को फ्रिज में ठंडा रख देते हैं, व्हाट डज हैपन, दैट वाटर इट चेंजेस टू सॉलिड. ओके, अगर उसी सॉलिड को जो हमारे पास आइस की फॉर्म में होती है, मैं उसे हीट देती हूँ, इट विल ट्रांसफॉर्म इनटू द लिक्विड. एग्जैक्टली. एंड अगर मैं उसी लिक्विड को फर्दर हीट करती हूँ, इट विल ट्रांसफॉर्म इनटू द वेपर्स, दैट इज़ अ गैसियस फॉर्म. सो फ्रॉम हियर we can get that solids are convertible to the liquids, liquids to the gases, and vice versa. And this is something which is very important about the physical categorizing of these matter. So the solid, it could be easily converted to a liquid, and liquid can be easily converted to a gas. Now if we want to convert solid to the liquid, we have to heat it. And if I further want to convert liquid to the gas, मुझे उसे भी heat करना पड़ेगा. मैंने आपको example दे ही दी है. The ice we use, the ice which is a solid form, अगर मैं उसको heat करूँगी तो I'll get the water. अगर उस पानी को भी मैं heat करती हूँ तो I'll find the vapors of the steam. Those steam vapors, they are a gaseous form. Now from here I can come back to this particular one. After cooling it, once I'm cooling the gas, अगर मैं गैस को कूल कर रही हूँ, I can get a liquid. If I'm just cooling that liquid as well, I can get that solid. That is the, we all know that making up of the ice, which is a better example to explain this thing. So I hope this concept is very clear. So the next step is the chemical classification of the matter. We have already done the physical classification where we get to know that हमारा जो matter है, it's composed of, or it is categorized into the three things: solid, liquid and the gas. Now we are going to study the chemical classification of matter. Physical classification, if you remember, that was on the basis of the physical structure. लेकिन अगर मैं chemical classification की बात करती हूँ, इसका मतलब क्या है कि जो भी chemical changes उस matter में हो रहे हैं, उसके basis पे what are actually the classifications of the matter we can have. So the very first thing, chemical classification of the matter is a mixture. and the other one is the pure substances. Now, if I talk about the mixture, mixture is further categorized into the two different categories. The very first one is a homogeneous and the other one is the heterogeneous. Moving ahead to the pure substances, it is broadly categorized into the elements, into the compounds, and as well as the mixtures. So when I talk about the pure substances, they are categorized into the elements or they are categorized into the compounds. When I talk about the elements, they are further classified into the metals, non-metals and metalloids. When I talk about the compounds, they are categorized into the organic compounds and inorganic compounds. So we will study about all these one by one. So starting from the mixtures, they are actually the substances which are formed from more than one kind of the components or the constituents. मतलब कि हमारे अगर पास एक substance है, let's say lime water or let's say sugar water. Now in the sugar water, I must be having, sugar as well as the water molecules. So when I have that mixture with me, I could say that this is a particular substance which is made up of the combination of two substances. क्योंकि इस mixture में अगर sugar water है, उसमें definitely थोड़े particles sugar के होंगे and there will be the particles of liquid, that is a water, and this give rise to a mixture. Now, is this mixture a homogeneous mixture or a heterogeneous mixture? It is a homogeneous mixture if I'm, stirring this sugar till there is no particle which is left. So when I talk about the homo, the word homo itself means something which is same, जिसमें हर एक चीज यूनिफॉर्म रहती है. Let's talk about it. When I talk about the homo, the very first thing, this word itself means same. Homogeneous mixtures means the composition of that particular mixture, it remains same throughout. It remains uniform throughout. Again, I'll give you the same example. For example, when we are adding the sugar to the water, we get a mixture which is a homogeneous in the nature. But let's talk about the other mixture when we are adding a sugar in such a huge quantity that the particles, they are not able to dissolve in it. Then I would say that this is a heterogeneous mixture. Heterogeneous mixture means now the two different kind of the particles are easily seen over there. Hetero is something that means different. So this is something from where we can get easily define it. Hetero, that means different, and geneous, of the different categories. So when there are the two different kind of the particles making up the mixture, they give rise to the heterogeneous mixture. Clear? The another example of the heterogeneous mixture, it is mixing of the sand in a water. We know that both the particles are clearly visible. The particles of the water and the particles of the sand. We can't separate them. That is where we could say that is a heterogeneous mixture. There is one thing which is very important about the heterogeneous mixture. That is what? We can easily separate the two particles from each other with the help of the physical methods. Let's say it could be the hand picking or it could be the distillation. So there are the different physical methods that could be used for separating the different mixtures, or we could say that separating the different particles from the heterogeneous mixture. Moving ahead, first of all, let's see the difference between the homo and the hetero, and then I'll make you clear about the pure substances and its different categories. So for example, state the difference between the homogeneous mixtures and the heterogeneous mixture. So when I talk about the homogeneous, as I already gave you the example, this is the one made up of the same particles or same type of the constituents that are uniformly combined. But when I talk about the heterogeneous mixture is what? The composition is not uniform. Composition varies. When I gave you the example of that sand and water, you must be aware that if I say this is the water which is being contained in a container, and there it carries these sand particles. Now we could clearly see there is a different two particles over there. So when we talk about the heterogeneous, we can easily figure out there is a separation line between the two particles. So there is always a separating boundary in a heterogeneous, a boundary which is there to separate the two particles. For example, another example is the pouring of oil on the water. If we are pouring oil on the water, we could see the two different categories. We could see the two different particles, oil having a different layer and the water having a different layer. So there is a line of separation which is, separating these two kind of the particles. Moving ahead, if I talk about the homogeneous, there is no line of separation. So I hope the difference is clear, and the third point you can make out is the example. Here I would give the example of dissolving of sugar in a water. Here I would give the example of pouring of the sand in water, or we could say that mixing of sand and water, mixing of oil and water. That is the one example here we can give. So this was about the mixtures. Moving ahead, we will talk about the elements, we will talk about the pure substances and its further categories. So, there are various pure substances that we find in our day-to-day life, but we might not be aware that they are actually products of chemistry. For example, if I talk about the pure substance, the very first thing, the name itself says something which is made up of one particle, something which does not contain any other any other constituent or any other particle. What a single particle should be there. In that, I can give you the example of the gold, silver, because gold, which is Au, it's made up of the one particle only. The particles of gold you will find out everywhere. If we talk about, the one brick of the gold, then silver, it will be having the constituents of the silver only, no other constituent. But if I talk about water, is it a pure substance? Yes, it is a pure substance, because every time we are having the particles of water, we are having the water particles, it will be carrying the hydrogen and the oxygen in the ratio 1:8. That means the composition is uniform, and this is a particular substance which will always be made up of the 2 parts of the hydrogen and the 16 parts of the oxygen. So I would say that yes, this is a substance which is pure in the nature. So these are the few examples of the pure substances. Moving ahead, the categories of the pure substances, we have elements, we have compounds, as already told to you people. So in the elements, I told you it is further categorized into the metals, non-metals and metalloids. So when I talk about the metal, we use the metals in our day-to-day life. For example, any iron rod which we are using. For example, aluminium foil on the burfi, aluminium foil used to wrap our food, that is also a metal. So what can we say about the metals from this? Metal is something which is having a shining luster. Metal is something which, it's a good conductor of the electricity. The iron rod, it's a good conductor of heat as well. Metal, they are the substances. Talking about the aluminium foil, they can be easily, formed into the sheets, or moreover, I could say that it could be easily beaten up into the wires, I could say that. So metals, they are malleable, and metals, they are ductile. So these are the properties we can mention about the metals. Moving ahead to the non-metals. Non-metals, I would say that the different kind of the gases, hydrogen, oxygen, non-metals, or we could say that the iodine. Yeah, so these are the particles, we could say that these are the substances which don't have the luster. But they are the substances, we would say that they are the poor conductor of the heat and the electricity. Exceptions are there, but figure it out. What is the exception of a known metal, which is a good conductor of the heat and electricity? Moving ahead to the metalloids, I would say that they are having the properties in between the metals and the non-metals. Metalloids, for example, silicon, which is being used in the transistors or in a day-to-day life in various things, that is a metalloids, having the properties in between metals and the non-metals. Silicon, germanium, these are the particular one which comes under the category of the metalloids. So this was the one classification of the elements to the further three different categories. Moving ahead, compounds. Something which is very interesting now. Compounds, they are the substances which are actually formed by the combination of different elements. It could be the metal, it could be the non-metal, having a different kind of the forces which are operating between them. When I talk about the compound, the very first thing about the compounds, they are always formed by the two or the more combination of the metals or the non-metals. Let's say water, it's a compound because it is being formed by the combination of hydrogen and the oxygen. Hydrogen plus oxygen, it combines to give us water. Let's talk about glucose, C6H12O6. Again, it is a compound which has been formed by combination of carbon, hydrogen and the oxygen, different elements, and they are combining together to give us a single compound. Now something which is very interesting about compounds, hydrogen and oxygen, they combine together to give us the water. The property of the compounds will always be different from the properties of the elements. For example, hydrogen, it is an element which does not support combustion, but oxygen is it's a element which is there to support the combustion. So both of them having the different properties. But when I talk about water, it's used for extinguishing the fire. So from here, as we get to know that the elements having the different properties, but the compounds, it's having a totally different property. So this is what we call the properties of the compounds. They vary from the properties of the elements. So we were talking about compounds. Compounds are basically the substances that is actually formed by the union of two or more elements, and they are combined together by the definite proportions, by the means of the percentage or by the means of the weight. Anything it could be there. When I talk about the water, which is formed by the combination of hydrogen and oxygen, this is a particular compound which will always be formed by the combination of the 1:8 ratio of the hydrogen and the oxygen. So I would say that whenever we are having the compound water, it's always formed by taking 1:8 proportion of hydrogen and the oxygen. Moving further ahead, there is something which is very interesting about the compounds. Now elements, hydrogen and element this oxygen. Hydrogen is a gas which is combustible, that easily catches fire. But when I talk about the oxygen, it is a gas which helps in the combustion. For example, burning of the wood, हमने देखा ही होगा, उसमें oxygen is very very important so that it can catch the fire. But when these two elements they combine together, they give us water. And this water, which is a compound, it's having totally different properties, It's having the properties different from hydrogen and oxygen, because this is the one which is actually helpful in, we have to extinguish the fire. So water is having a totally different property. Now compounds, they are further categorized into the inorganic and organic compounds. When I talk about the inorganic, it means these are the compounds which are obtained to us from the non-living organisms or from the non-living sources. When I talk about the organic, that means these are the substances which are obtained us from the living sources or the living things. For example, glucose, it's an organic compound. Other category, it could be the sodium chloride, because it is something which is obtained us from the non-living source. So on the basis of their sources or on the basis of the way of their production, we can categorize the organic and the inorganic substances. That is all about the pure substances, the compounds and the elements. Mixtures, we have all studied in that particular one. So this is actually the one part of this chapter where we have studied about the matter, the different classification of the matters, how they vary from each other. So till here we have studied about the different categories of the matters and we studied their subcategories as well. Now here we will be there to talk about the properties of the matter and how we can measure their particular properties. So we know that there are basically two kind of the categories of the properties. It could be the physical property on the basis of the physical structure. It could be the chemical properties on the basis of the chemical changes that are happening there. When I talk about the physical properties, for example, the physical properties that are on the basis of the structure that I can tell, that I need not to know what are the chemical changes that are occurring behind it. The very first thing, let's talk about temperature. When the temperature gets higher, we get to know, because the perspiration that we get, it let us know that yes, the temperature is too high now. But on the other hand, if I go to the Shimla, I will find it out that I really start feeling cold. It is because the temperature has been down there. So this is something which I need not to know about the chemical changes occurring behind it. It's only that I get to know from the things that are happening that yes, the temperature has gone down or the temperature is up. This is a physical property on the basis of the physical structure rather than taking into consideration the chemical changes taking behind it. This is actually the one example. Moving ahead to the chemical properties, I would say that the chemical properties of any matter, they are actually the properties that let me know that what are the changes that are chemical changes taking place in that particular matter. For example, let's talk about, when I talk about the chemical changes, it might be to know the acidic nature, it might be to know the basic nature or the neutral nature of that particular substance. It might be there to know, we could say that the reactivity, the combustibility of that particular substance, that how the elements they are reacting together. These are all that make up, we could say that the chemical properties of the substance or the matter. In the physical properties, there was the one example that I gave you about the temperature. Other could be the odor. The other, it could be the physical appearance as well. And it could be their melting point, it could be their boiling point and the density. So these are the properties we could say that a matter actually undergo. There might be the physical properties, for example, sodium chloride. The odor, it has no odor, but when I talk about the texture, when I talk about the density, I could get to know that okay, there are these small grains of the salt in my hand. Physical appearance, it's the whitish in the color. The melting point that I get to know with the help of the various chemical methods, and the boiling point as well. Talk about the water, we get to know its boil. This is the position where, or we could say this is the moment where it has started boiling, when we start to get the bubbles of the water. So these are the properties that I would like to mention in the physical properties of the particular matter. Moving ahead, when we have the physical and the chemical properties, there are the physical quantities, which are dependent upon these properties. Now, what do you understand by those physical quantities? Physical quantities, when I say, it means that a particular quantity that can be measured very easily. So, when I say that this quantity, it can be measured, it means that my observation can help me to know what could be the particular value for that measurement. For example, if I talk about my height, I need to measure it. It is a quantity that I need to get the measurement about. So, physical quantity is any quantity that demands measurement. Or we could say that it is any object actually. It's any object that could be measured is a physical quantity. The one example given by me to you people is my height. That is a physical quantity that could be measured. Now, if I talk about my height just in a centimeters, if I say it's 168 and it does not provide you any unit, I just give you the number. Will you get to know what is this 168? I don't think that if I just give the number 168, you will get to know this is my height. When I write about 168 centimeter, you get to know that, okay, this is something which is talking about the height, or it could be something which is talking about the length. So, when we are having a particular value and a particular unit, we say that this is a particular thing which is representing a quantity. Now here, this is actually representing a unit, this physical quantity which is a length. So from this value, I could say that every physical quantity, it carries a value, and every physical quantity, it has some unit associated with it. For example, I gave you the example of 168 centimeter, a numerical value that a physical quantity that must possess, and this is something a unit, centimeters, that a particular physical quantity must be there to carry out. Now, what is unit? It is basically a standard which is adopted by the different international systems to give a representation to the particular quantity. It is something that helps us to distinguish which is the particular physical quantity. For example, I can't say my weight is 58 centimeter. I could only say my weight is 58 kilogram. That means to say that kg is something which is a standard that has been taken, and this standard is not only used in India, what we could say that in different countries this is a standard which is taken. So unit is basically a standard that help us to know the measurement of that particular physical quantity, and these are the standards adopted all over the world for measuring of any kind of the physical quantity. In this way, I would say that we are having the two different categories of the units. I would like to mention the definition of the unit. We would say that a standard that helps us to know about the physical quantity. Now, when I talk about the unit, I already mentioned that unit is further divided into the two categories. Units might be the fundamental units, or it could be the derived unit. When I talk about the fundamental units are the basics. Fundamental is something which is very basic, and when it is a basic, does it depend on anything? No. So when we talk about the fundamental, that refers to something which is not dependent on any other quantity or any other units. So fundamental units are the units which are not further divided into any kind of the units. They are independent in themselves. They might be the basis of any other further unit, but they are not obtained from any other unit. For example, kilogram. This is a very basic unit of the mass. Kilograms, grams, these are the basic units of the mass, I would say that, which are not further dependent on any of the category or any of the source. On the other hand, if I talk about the derived units, as the name says, derived is something which is obtained from other unit or the other quantity. So derived is a word that the definition itself refers to. Derived unit is a unit which is obtained from the fundamental units or which is obtained from the further other units, and this is the one which is breakable, which could be divided into the one or the other categories. For example, area. Now area, we know that it could be side square, or we could say that side into side of a square, and side, if we have to measure, it will be into the length. Fine. And if I talk about the unit of the length, it could be meter, that is a square meter. So when I talk about the derived units, it means it's not a fundamental or a basic unit. It is derived from the combination. It could be multiplication or it could be addition, subtraction, anything. It's obtained from it. For example, let's talk about force. Now force, it's mass into acceleration. Mass, it's having the units kilogram, and acceleration having the units meter per second square. So from here I could say that this is a particular unit which is derived in the nature, because it's not at all having any of the unit which is fundamental of its own. This particular, it's a derived one, because they are formed by the combination of the three further units, that is of the mass, meter, we could say that of the distance, and the per secure second, that is of the time. So there are the three different units that are combining together, and they are giving us the one derived units. So this was the concept related to the units, the fundamental units and the derived units. Further, we have the different systems of units that are the basic, or we could say that are standard in itself. For example, SI, which is the System Internationale. It has been derived from the French phrase which means Internationale system. So SI, which refers to the System Internationale, it is derived from the French word which is Internationale system. Fine. So SI system, this is the one system that gives us the 7 basic or the fundamental units, which could be further used to figure out or find out the different derived units. So these 7 units, first of all I will mention about the physical quantity and then their units. Let me tell you one more thing, that SI system, this is a system which is adopted for every kind of the physical quantity, and these are the systems which is the basis of any kind of the measurement in either in the physics, either in the chemistry or anywhere. So this is a system which finds its uses in the various categories. It finds its uses in a very wide proportions, in the wide applications of the different measurements. So physical quantity, the very basic length, its unit meter, represented by m. The second one, mass, its unit kilogram, which is in the SI, represented kg. Third, time, its unit second. Temperature, having a unit, SI unit, Kelvin, represented by K. Seconds, represented by S. Then we are having the current, having the units ampere. Next, having the luminous intensity, having the units candela. And the last one is the angle, which is measured in the radians. So I hope these 7 basic units are clear to each and everyone. I'll repeat it again. Length, it is measured in the meters. We are having the mass, which is measured in the kilograms. Time, in the seconds. We are having the temperature in the Kelvin. Current, in the ampere. We have luminous intensity in candela, and angle in the radians or steradians. It will vary accordingly. The one more thing, there is one other one, that is a mole, which is used to measure the amount of substance. So these are the units which fall under the category of the System Internationale, and you will find its uses in the further chapters that we are going to study, whether it is related to the chemical kinetics, the chemical reactions, or it is related to the equilibrium or the thermodynamics. We will find out the uses of these physical quantities and the units over there. Moving ahead, we are having some of the prefixes that we need to learn, which is very, very important to learn for any of the student. And I'll be there to mention those units over here, the prefixes that could be used and how to use that particular prefix. We have just studied about the different kind of the units, the fundamental and the derived units. Here we are having the various prefixes which are implemented in the SI system. These prefixes are very important to know when we have to convert one unit to the another unit. As our next video that will be on the conversion of the one unit to the another, it's very important to know these basics over there. 10 raised to the power minus 1, that refers to the deci and being represented by D. 10 raised to the power minus 2, centi and C. Minus 3 to the milli, 10 raised to the power minus 6 micro, 10 raised to the power minus 9 nano, 10 raised to the power minus 12 pico, 10 raised to the power minus 15 femto, and these were actually the units which were in the negatives. We are having the negative powers. Moving ahead, there are the units carrying the positive powers. For example, 10 raised to the power 1, deca, represented by small da. Hecto, represented by H, like 10 raised to the power 2. 10 raised to the power minus 2 was the centi. Fine, 10 raised to the power 2 is a hecto. 10 raised to the power 3 is a kilo in small k. 10 raised to the power 6 is mega, but 10 raised to the power minus 6 it is the micro, represented by mu. Minus 9 is a nano and the plus 9 is a giga. 10 raised to the power minus 12 is a pico, but on the other hand 10 raised to the power plus 12 is a tera. 10 raised to the power 15 peta, represented by capital P, but here 10 raised to the power minus 15 is a femto, represented by small f. Make sure that we are clear with their symbols, because when I talk about the pico, it should be the small p. When I talk about the peta, it should be the capital P. So this is something which is very, very important. So from here, I believe that you should also know some of the rules and regulations to be followed when you are representing any physical quantity with its units. For example, if I have to write about the two units together, let's say kilogram, and I have to refer to it centimeter. Fine. There should always, the very first thing, there should always be a gap between the two, or I should be there to use a symbol which is of the product. Kilogram, centimeter. The other unit, let's say M and K. If I am writing it in this way, I might get it is milli and this is the Kelvin, because Kelvin, which is a unit of the temperature, represented by K. Fine, if I am writing it this way, M and the capital K, let's talk about it. But if I am writing it this way, I get to know that there are the these are the two units, which one is representing the meter, other one is representing the Kelvin. But here MK, if I talk about it, it represents, I could say that it could be a milli Kelvin, a milli Kelvin. No, not at all. A meter and the Kelvin. So I should be very clear that what I do need to represent. When I am representing the two different units, make sure that there is either a space in between them, or they are being taken as a product of the two units. Fine. Moving ahead, whenever I am representing any units, for example, I have to say meter Kelvin. So I should be there to represent them either in a complete written form or in a, in a manner I just told you people. It should not be that I am writing the one unit in a meter and the other with its symbol. No. If you are following the symbols, please go with the symbols only. You need not to write one I would say that you need to write in a words for the one unit and writing in the symbol for the another. This is not the system which is followed by the SI. This is a wrong system of representing the units. So make sure that this is something which is very, very important. You are taking notice of this thing. Thirdly, when I am writing the centimeter, let's talk about 1 centimeter, 1 square centimeter. I know that centi is something which represent what? 10 raised to the power minus 2. So can I write, as we know that 1 meter is equal to the 100 centimeter. Am I right? So can I write 1 centi as 10 raised to the power minus 2 and square meter in this way? And can I write 1 square centimeter is equal to the 10 raised to the power minus 2 and When I talk about the square meter, can I write raised to the power 2 and square meter? And hence it will be 10 raised to the power minus 4 square meter rather than minus 2. Is it clear? First of all, I mentioned about the centi, which is minus 10 raised to the power minus 2, because it was a square meter, and I would have taken, I'm really sorry, I would have taken it here because it's the square meter, so it will go with the square of this particular one, and hence 10 raised to the power minus 4 square meter. That is about the representation of the units, I would say that. So that's all about this particular topic related to the matters. We have studied about the chemistry, its application, matters, its different categories, the units, and the various way how to represent that units, the prefixes related to that. That was all about this particular video. In the next video, I'll be there to present a different kind of the topic and will be there to make you more clear about some basic concepts of chemistry. Thank you.